Hello everyone, thank you for joining our webinar. My name is Carla Mayberg, the Manager, Marketing Communications here at GeoQ Australia, and I'll be your host. Today we will be reviewing the LP360 drone integration for the DJI L1, a sensor that complements our professional grade line of TrueView technology by adding an entry-level option. For the presentation, we'll begin with an introduction from our General Manager, Mark Hickey. Then Matt Rosenbaum, our Sales Director for LP360 Drone, will give us an overview of what you can do with the software. We'll follow that with a special presentation on the ZenMuse L1 from our friends at DJI. And then Matt will conclude with a demonstration of L1 processing with the LP360 drone. Please submit any questions in the GoToWebinar chat on the left-hand side of the screen, and we'll have a response for you within 24 hours. Now I'd like to introduce the General Manager of GeoQ Australia, Mark Hickey. Welcome, Mark.
Good morning all, welcome to our webinar and thank you for the introduction, Carla. So thank you all for joining us. It's amazing to have you with us. We appreciate your time and appreciate that you're very busy. So thank you again, and we certainly aim to bring you some great content. My name's Mark Hickey. I'm the General Manager and Director for GeoQ Australia. At GeoQ Australia, we mainly work with the civil, construction and mining industries, and with specific regard to drones and drone and LiDAR. So for this webinar, we're very pleased to be working with DJI and GeoQ Group. And the point of the webinar is to highlight the value of using our GeoQ software with the DJI ZenMuse L1 LiDAR system. The L1 is a great and economical system, as you may know, and produces great deliverables via DJI Terra software. I would also like to welcome and introduce Lumen from DJI, who will also speak, and we also appreciate the input to date from Kui Heng and Crystal, also from DJI. So where we come in is through the use of our GeoQ post-processing software, and this further enhances and maximizes the data produced by the ZenMuse L1 and Terra software. Now, our software normally works with our GeoQ TrueView LiDAR systems, although fortunately it can also be used to good effect with the ZenMuse L1, and that's as a guest sensor. So looking at our software, the name LP360 has been around for many years, and this has primarily been a feature extraction package. And since the release of our TrueView LiDAR system back in 2019, it has been teamed with a version of LP360 known as EVO. So EVO was used for post-processing the LiDAR data, and it also had those LP360 features for conducting feature extraction and classifying your clouds. So to simplify things, we now refer to this software as LP360 drone. So now EVO, which is used with the L1 and of course our TrueView LiDAR systems, is going to be called LP360 drone. So we're working hard to simplify things a little bit. So hopefully I've explained that okay. So looking at the specific benefits of LP360 drone with the L1 data, this covers a number of things and areas, but one of the big things is strip align as a major benefit. And furthermore, things like bare earth and stockpiles, rail and wire identification are quite big benefits. So the mining area in particular is an area that we believe we can benefit in large ways through the use of these systems, so the hardware and software. Photogrammetry has been used for many years for gaining stockpile data, and through the use of the L1 Terra and LP360 drone, we feel that there's quite significant benefits, and which can create genuine, arguments and reasons for miners to give LiDAR a go and try the L1 and our LP360 drone software. So later, my colleague Matt from GeoQ Group will explain this in greater detail, and certainly he'll go into a bit more detail than I've just done. So before I finish, I'd like to thank DJI and of course GeoQ Group for their great partnering, and our local staff for their great commitment, and especially to you for joining us for this webinar. So hopefully you enjoy it and get something from it. So thank you again, and have a great day.
Thank you so much, Mark. Next up, please welcome Matt Rosenbaum, the Sales Director for the LP360 drone.
Hey everybody, thanks for joining us today. My name is Matt Rosenbaum. I am the sales director for LP360 Drone. I've been with MD Group for almost 5 years now, so I've got a lot of experience not only on the hardware side, but also with on the software side, processing data on this new journey, kind of bringing LP360 to everybody, so they can kind of see how it can help enhance data from all different lidar sensors. Before we get started, just to kind of give a quick little overview of LP360, this software is great for a multitude of things, but I think the ones, kind of the high points that make it shine are kind of highlighted here on the screen. Anything from your basic classification to brake lines to visualizing the data in a multitude of different angles, such as 3D view, plan view, profile view, you name it. You have so many different ways you can analyze the data. Managing various spatial reference systems, QA and QC the data, and a lot of your product generation. You can finalize your deliverable here in LP360 Drone, or you can get it to a point where it's ready to export and bring it to a multitude of other softwares like AutoCAD, Civil 3D, you name it. LP360 Drone includes a multitude of different tools, such as your automatic and manual classification to get down to the ground. If you're looking to ground classify, if you're looking to build 1 foot contours, it's great for that, but also classifying, looking for building footprints, classifying our power lines, identifying various objects and the heights of those objects if you're looking to do different types of surveys around airports and whatnot, and make sure, height studies and whatnot. You have all those tools right here within LP360 Drone. You can take the raw data strictly from your LiDAR sensors, import that LAS file, build on-the-fly contours, especially as you continue to classify out the trees and whatnot. You can see those contours change. Export DEMs, do automatic wire extraction, catenary curve fitting as well, volumetric data, rail extraction, you name it. There's so many different tools that we're continuing to update and make LP360 into the powerhouse that it is already, and continue to push the envelope and make it even better. LP360 Drone provides you the security to address any inaccuracies of your data set. First starting with addressing the noise. With the DJI L1, it is a little bit inherently noisier than a lot of the LiDAR standards out there. So in order to get rid of that noise and bring it down to a more manageable solution, so when you do start to build your surfaces and whatnot, it gives you a more accurate representation of the ground. From there, you can actually import your ASCII text files, your CSVs, to make sure that your point cloud is lining up with the check shots that you took out in the field. Once you get those uploaded, you can run the report for various different reasons, from a 10 or from the nearest points, based on the parameters that you have set. If you do have any inaccuracies, you can debias the Z or debias the point cloud and shift the whole point cloud to get rid of that mean error that you have from the data set, giving you the most accurate data set possible with this particular sensor. With LP360 Drone, grid to ground is no problem. So we have a suite of tools to manage all the coordinate systems that you might be working in, including local coordinate systems, especially for those, which is especially beneficial for all those construction companies that might be working in local coordinate systems, or 1,000 grids, or 500 grids. You have the tools within LP360 to make sure that you can work in the type of workflows that you're currently working in, regardless of the coordinate system. LP360 Drone simplifies the workflows to get your DJI L1 data, from very dense data down to something more manageable, allowing you to get it ready to export into various CAD softwares. Before you even do that, you can also build your brake lines and enhance the surface that you're building with using those brake lines. Get it down to a much more manageable data set that you can bring it into the various CAD softwares and finalize your deliverable in there, if that is what you're looking to use this system for. One of my favorite tools within LP360 Drone is the ability to use this colorized point cloud in various different mediums, such as the 3-dimensional view, which we talked about earlier, but also updating it and using it with the Image Explorer tool. You can actually drive to an image by clicking on a point of the point cloud. So if I wanted to click and visualize all the images that were taken on this part of the point cloud, if I click on that point cloud with the Image Explorer tool, it'll actually open all the images that were taken in that particular location. This kind of gives you a much better example of that. For instance, if I were to click on this part of this power line, it's going to pull up all those different images. I can actually click on that point on multiple images, and it'll give me a 3D point, so an XYZ location for that particular point. So not only is LP360 drone, enhancing all the surveying you can do with the L1, but also allows for some great tools for inspection, especially when flying various critical infrastructure like power lines, towers, you name it. One of the most important features within LP360 is the ability to do strip align. And what strip align does is it actually addresses the inaccuracies between the strips of the data created from the L1. So if you do have any misalignments from one strip to the next, when we actually bring the data in from DJI Terra, we upgrade the last from 1.2 to 1.4, assign a point source ID to each one of those strips, and allows us to see if I have any issues, alignment issues, which we'll see in the live demo and how we address those. So strip align essentially uses an algorithm to actually take those two strips and match them like they're supposed to be, getting rid of inherent noise if one strip is sitting on top of the other. And the big benefit of this is you're able to see this because of the generation and everything we do in upgrading that point cloud to the latest and greatest and assigning a point source ID. Whereas straight out of DJI Terra, it's all considered one strip and is a lot harder to see if you have any of these issues with your LiDAR data. So many of you are probably asking why the DJI L1. You know, the DJI L1 is our recommended entry-level UAV LiDAR payload. Of course, we're going to recommend our TrueView lineup of LiDAR sensors. But if you're looking to start, get your feet wet, the DJI L1 is going to be a step above most of your other LiBux Avia sensors out there. One of the big benefits of it is a gimbal mounted, so it avoids roll holidays and optimizes the flight time. It also includes a seamless camera integration, optical flow aiding for improved heading, and it's less expensive than other LiBux Avia based systems. The most benefit you'll see, and which we'll hop into next, is integrated into LP360 drone with the post-processing workflow. So you can get the most out of that sensor when using LP360 drone and updating and enhancing the LiDAR data from this particular sensor.
Thank you for the information, Matt. Now I'll turn things over to DJI to learn more about the L1 sensor.
Hi everyone, welcome to today's webinar. Thanks for taking some time to join. We will focus on two main topics in today's presentation. The first is the DJI L1 software update, and the second is a brief introduction of the upcoming Terra webinar. So before we start, please allow me to make a quick self-introduction. My name is Lumi Xu. I'm the new DJI solution engineer who will be based in Australia after training courses at headquarters in China. I'm an energetic, passionate individual with a strong sense of responsibility and always aim to deliver good performance. I intended to use my knowledge and my skill to support DJI Enterprise Australian business, including public safety, surveying, and mapping. And we will continuously promote drone application in energy industry with electricity education background and job experience. This is my honor to hold this meeting today, so thank you for your attendance again. So let's move to the next part, is the L1 upgrade operation guidebook. The Zamus L1 firmware has been updated from the V3 to V4, so don't forget to download the latest version in order to avoid the malfunction of our products. And there are three outstanding package updates regarding the L1 V4. The first is the terrain flow optimization to improve efficiency and enable simultaneous terrain flow and calibration. We have utilized the advanced algorithm to reduce the total length of the route and the number of the waypoints. For example, previously you may need conduct a 4,000 meters route length to complete the task, but right now you just need 3,900 instead, which means the efficiency has been improved by 10%. As for the waypoints, compared to the previous 120 waypoints setting, and now you just need 30 instead based on the V4, which indicates 80% efficiency increase. And we actually going outside and demonstrate the test comparing the different performance between V3 and V4 at the same platform. So here are some parameters and results I would like to share with. For the V3 terrain, following the actual flight time is around 24 minutes on the mountain area with a drop of 200 meters. and 0.6 square kilometers survey area, 1,000 meters flight altitude, and 10 meters per second flight speed. And the last is the 10% lateral overlap, while the waveform only costs 14 minutes using the same KML file, which means the condition is exactly the same. After calculation, the efficiency improved around 41%, which is impressive. So for the next part, it now can be automatically calibrated in waypoint, linear, and oblique flight after enabling calibration option. The calibration strategy is the acceleration and the deceleration will be conducted at the start point and end point of the mission. If the flight time between two waypoints over 100 seconds, it will automatically calibrate in the middle point. And also, for the visible camera of L1 supports generating PPK files. Now, in both manual and mission flights, PPK files of the visible camera will be automatically generated, including timestamp, MRK, and PPK raw being in file. And you can extract both of the files from the SDK cards depending on the situation you have. And finally, I would like to introduce the DJI L1 Operation Guidebook, which is a wealth of knowledge we would like to deliver to our customers and the end users. We put a lot of effort to edit it, and you can find a lot of examples regarding the L1 operation, like the proper data collection, camera calibration setting, different use cases, post-processing, and a lot of good useful information you have a chance to review. I would personally encourage you to have a careful read, as the use threshold of the L1 products is relatively high, and a certain of knowledge of surveying and mapping is required as the basis. So sometimes misunderstanding and wrong operation may occur, but with this operation guidebook, you can avoid all of them, maximizing the performance of the products. And this part is the L1 grid manual. It will be released in August. The purpose of this manual is to help you properly collect LiDAR data for the power lines, as the electricity industry is quite different from the others. There are four main components. The first is the preparation, and second is route planning, and the third is the data collection in the field. The last is the data processing. We have disclosed some of the parts of the menu here. These illustrations precisely explain how we can achieve a correct data progressively. For example, if you add two extra points, one before the first pylon and one after the last pylon, you can ensure that the point cloud of the first and last pylon is fully collected, and there is sufficient distance for IMU calibration, as IMU calibration requires a distance of at least 30 meters. So the first waypoint and the second waypoint should be left at least 30 meters away. Same applies to the last point. Okay, let's move to the L1 training course. Here is the tutorial video to help you better understanding our product L1 from the beginning. So let's go through short footage for each chapter to see what it looks like. The first chapter is the introduction. So yeah.
Hello, and welcome to the first module of the DJI Zenmuse L1 training course. This module forms part of an informative series aimed to provide you with a comprehensive understanding of the Zenmuse L1. Throughout the course, you will begin to understand the best practices used to obtain good quality and accurate data from your LiDAR surveys. Given the nature of LiDAR, there will be guidance on all steps, including hardware preparation, mission planning, mission monitoring, data processing, and sensor calibration. There are no prerequisites to this course, however feel free to pause and research specific areas if you would like to understand the underlying principles in greater detail. Importantly, this course has been designed to provide you with the ability to obtain data that is both good quality and accurate without any previous experience with LiDAR data. If you have used LiDAR units in the past or worked with the data closely, then you may notice that some steps are very similar to other systems and workflows. Before collecting data, it is very important to know what the system can and can't do, and likewise what components are involved with the unit itself. Our first module will aim to provide us with a familiarization of the characteristics of the sensor and the technical specification of the hardware and software involved.
Okay, let's move to the next part. Is the GNSS position.
Welcome to the second module of the ZenMuse L1 training course. This lesson is designed to introduce you to everything there is to know about generating and applying highly accurate GNSS positional corrections into your L1 dataset. The ZenMuse L1 has been designed around the application of surveillance. Therefore, applying a form of positional corrections to your data is fundamentally essential. Without the application of such corrections, your data will not process in DJI Terra. Throughout this module, we will introduce you to the fundamentals of GNSS RTK and explain how your corrections can be derived and applied in real time, either by establishing a connection with the DRTK2 mobile base station or from using an internet service to source your corrections. As an alternative method, we will then also demonstrate how to post-process GNSS corrections using a post-processing workflow if you don't have access to the internet or a DRTK2 when out in the field. Firstly, let's look at a workflow for obtaining positional corrections using a...
Okay, the next part is the basic LiDAR technology.
Hello, and welcome to the next section of your L1 training course. In the first part of this section, we will introduce the fundamentals of LiDAR technology, with specific emphasis on the technical parameters of the ZenMuse L1. This will include details about the return mode, sampling rate, scanning mode, alongside an introduction to all of the parameters. We will then apply our knowledge of L1 parameters to specific mission types, providing recommendations for each. In the final part of this section, we will provide detail on the calibration procedure of the L1's IMU. Firstly, we will begin with a short introduction into LiDAR technology. LiDAR stands for Light Detection and Ranging, first hitting the market in the early 1970s, focusing on single beam profiling with the applications of documentary.
And the fourth part is how to collect data using DJI ZenMuse L1.
Section introduces the information needed to successfully capture and monitor your drone data. It will outline how you can employ ground control in order to assess the accuracy of the L1 dataset. For this process, we will be using an Emerald GNSS receiver, along with the same NTRIP license which was used to collect custom network RTK data. Finally, we will also aim to find solutions for certain issues that may arise when out on site. Ultimately, the aim of this module is to show how an L1 survey will generally be performed, and get you comfortable with the working procedures at hand. Firstly, I am going to provide a brief introduction to the survey area used to conduct our drone flight. The survey area presents a farm in the heart of Northumberland with a good distribution of both man-made and natural features. Generally, there is not too much dense vegetation, with only a small amount lining the railway line on the right-hand side. That is why dual echo mode was selected over triple echo mode, as it was not a priority for the LiDAR to penetrate a large amount of tree cover. Instead, the emphasis was placed on maximising the number of returns to the sensor and generating a high-density point cloud. The size of our survey area was roughly 0.05.
The next part is the generating point clouds using DJI Terra. Oops. Okay.
Hello and welcome to the section which introduces the first data processing module of the course using DJI Terra software. By the end of this session, you will have generated your 3D point cloud, which is geo-referenced in the WGS84 global coordinate system. It will also provide step-by-step instructions on how to generate a 2D ortho photo using the raw images captured by the L1 sensor. In the first part of this module, we will briefly introduce DJI Terra software and discuss the different processing options available. This first section looks at installing DJI Terra onto your PC. It will briefly introduce the different Terra packages available. There are 4 main packages available when you purchase DJI Terra. These are Cluster, Pro, Agro.
Okay, the last one is how to generate DTMS using TerraSolid.
Hello and welcome to the DJI Zenmuse L1 survey course. This section introduces the key information needed to classify and clean your point cloud data with TerraSolid. It will show you how to export your raw LiDAR data from DJI Terra into TerraSolid. Finally, a step-by-step guide for the processing wizard will be used to classify your point cloud before using the output control report tool to compare the point cloud to the true coordinates. The first step requires installation of the TerraSolid UAV bundle onto your PC. Type in TerraSolid UAV bundle onto your browser and click on the link that says UAV trial TerraSolid. Firstly, ensure that the PC is the same PC that was used to previously install the DJI Terra software. TerraSolid will automatically recognize the activated license on this account.
Okay, let's stop here and go back to the slides. If you want to learn more from this video, I will share this PPT at the end of the presentation, and you can just simply copy paste the hyperlink here into your browser and you can get access to the video. And next part is upcoming Terra V3.5 webinar, which will be held on 4th of August 2022 from 2 p.m. to 3 p.m. If you are interested in and want to be beneficial from this webinar, please don't hesitate to register here. And this slide shows the what will be presented in the upcoming webinar. There are 3 main parts. The first is the update as support for 7-parameter transformation of coordinate system, and the second part is as support for selection of horizontal coordinate system and vertical coordinate system for some countries like Japan, US, Germany, Denmark, etc. And the vertical coordinate system supports selection and import good GeoID files. And the second part is the optimization. The first is optimizes reconstruction error prompt and as troubleshooting guides. Second, increase number of blocks and as display of block name in auto and the customer size block splitting modes. And the last part is the glitch fix. The first one is file preview page is not updated when drags the page after post import. The second is the F3MB file could not be displayed properly when imported into SuperMap. And the third is the collision detection fails due to switching between different KMLs and the point clouds in detailed inspection missions. All of them has been fixed. So if you have any further questions, please feel free to ask or send us email. We really appreciate your attendance and feedback. Have a nice day. Bye.
Thank you very much. Now, to show you how to get the most out of your L1 data, we'll turn things back over to Matt to demonstrate processing with the LP360 drone.
What you're viewing here is LP360 drone. We're going to first start with importing the raw data in the DJI Terra project right here into LP360 drone, and then we'll work along the toolbar to update that data. So first things first, we're going to import a new cycle into the project. In this case, we're using a guest sensor from the DJI L1. We'll click next, and we're going to go and add the DJI raw folder. So this is going to be the Zenmuse folder. We'll select that, and then we'll have to go in and grab the folder that has our SBET, or the trajectory file, which is going to be in your DJI Terra project under your LiDARs folder. So select the LiDARs folder. Last thing we're going to do is we're going to add the Terra Labs a layer within this software. Next, we're going to name this webinar demo, and then we are going to select the correct coordinate system. This was actually in Alabama West ellipsoidal. Click next, and then we'll click finish. And this is just letting us know that the ellipsoid is already in the software, so we'll click yes, and everything is done straight from Terra. Once this is complete, it's also going to import the images, the base map, as well as our flight lines from this particular project with all our trigger events on there. All right, now that everything is uploaded into our plan view, you can see that we have our flight lines. We call it the heartbeat of how the drone was flying throughout the flight. All of our trigger events, our raw LiDAR data, and we can see that over here. So I can turn it off and on in the plan view as well. What we're going to do first is we are going to create flight lines. So we don't need the data on the curves. So we're going to create a flight line for each one. So we want to make sure we measure our shortest leg, which is roughly 450 meters. So when we do go to create our flight lines, we're going to say about 425, compute flight lines. And now we will have our 3 flight lines that we need to actually create the new LiDAR point cloud from. Now that we have our LiDAR, our flight lines, we can go and create what we call our true view trajectories, or our trajectories for this particular mission. Essentially going to add us point source ID to each one of these strips. We're going to retain all the photos within the flight line, and we're going to start at flight line 1. So this will take about a minute or so to create our trajectories. So our trajectories are complete. We will then, as you can notice, we are working from left to right on the point cloud up here, or on the toolbar up here. So we will then, we call read geocode the LiDAR. So with the DJI L1, as you get further away from the swath, the data does get a little bit noisier. So we actually like to clip the data from the DJI L1 from the 82-degree field of view that it has down to about a 60-degree total field of view. So we'll do that here. We'll clip it at 30 degrees off nadir, so 60 degrees total. And we're going to update and promote that last from 1.2 to 1.4, and we're going to read geocode the LiDAR. Click yes, and this will actually make us a brand new point cloud that we can actually compare to the original, and you'll see what we were able to do in the comparison between the two, and why this is important steps. So now we have 2 different point clouds. We have our original LAS from Terra, which you can see here, that has all the data, including the turns, and we're going to turn off this so we can see it a little bit better. So this is the original LAS. This is the new LAS that we just created. So you can see we just have the 3 strips that we created and nothing more. So the big benefit of the 2 is if I switch this over to point source ID, you can see I have my first strip, my second strip, my third strip. The original Terra LAS looks like this. So when we go and we click on point source ID, it's just one solid strip. When we do try to cut a cross section of this, you can see this data. If I switch it over to point source ID and we zoom in, we're going to make our profile a little bit smaller. Big. I'm going to switch it up here to view so we can view our cross section a little bit better. So here's a good angle where we can see our data, and we're going to make it a little bit smaller profile. We can see our point cloud and how thick it is. And as we get closer to the edge of the swath where we have overlapping swath, you can see it gets thin again, because this is where 2 of the edges of the swath are overlapping. And if we make it a profile, but you can see how thick it is because of the 2 strips sitting on top of each other. And then it'll get thinner and less noisy because it's just one strip of data sitting on itself. So with the data straight out of DJI Terra, you can't do much about this. When we update the data from and add a point source ID and actually clip the edges of that swath, where we get rid of this alligator effect, we like to call it, where it gets thicker towards the ends, it's going to look like this. So you can see I only have data from one strip here because we clipped it from that 80 degree to 30 degree. But as you start to scroll a little bit more to the left, you can then now it becomes a little bit more clear. That first strip, or that red strip, is sitting on top of that green strip when these are actually supposed to sit within each other. So what we're going to do is we're going to run our strip align tool to actually make that data fit within itself and give us a more accurate point cloud. So before we do that, I always like to make a shapefile that we can go back and assess this particular area, and just call this shape. Click that, and we're going to draw a box around this area. Call this calibration issue strip line, so we can actually come back and reassess this particular area after we run our strip line tool. So the strip line tool is right here on our toolbar, and we're going to run it with the new last file. We're going to call this new point cloud align LAS. We're going to submit the job, and it's going to take about a minute for it to complete. Once it's done, it'll actually send me an email, and it'll also, we'll see this up on the screen, have a little green flag letting us know that our data is completed. So now you'll notice we have a green flag over here letting us know that our job is complete. It took 1 minute and 4 seconds. We'll highlight it, click post process, yes, and now we're going to be left with a new point cloud called the aligned LAS. So we're going to switch it over, and we're going to run a profile in this particular area again. We're going to switch it over to our original Terra file. So this is the original file out of Terra. Here is our updated LAS, so you can see the 2 point clouds sitting on top of each other. This is our new aligned point cloud, so you can see each strip sits well within each other, giving us less noise already without even running any kind of denoising algorithm or whatnot. So when we do start to run that, it's going to give us a more accurate representation of the terrain. So this is the original after we updated and assigned a point source ID to each one of those strips. Here's the new aligned data set. So you can see how much more powerful this makes your DJI L1. You know, if you do have some issues in the data, you can now address them within LP360 drone. And then if you do need to run some kind of alignment like strip align, you're able to do so to make sure that your strips sit within each other and giving you more accurate representation of the terrain. So next, what we're going to do is we're actually going to run a quick, we call smoothing or denoising of the data set. This will actually get rid of a lot of the noise found from the L1 and give us some more accurate surface model when we do create that surface for this particular project. Currently, if we were to look at a tinned version of this project, you can see, you know, our terrain is a little bit, you know, noisy. It's got a bunch of triangles out there because of how much peaks and valleys that we have from how noisy this sensor is. So we're going to actually run in this same area the smoothing tool in our point cloud task to get rid of that noise. Just a quick sample so you can see the difference between a smooth and a non-smooth portion of this data set. I'll open up the point cloud task. We'll run smoothing, and we're only going to run in a small area, similar to what we have actually viewed the calibration issue or the strip line issue. So I'll just run a quick area here, and it'll take about 10 seconds or so for this particular area of the project. It'll leave me a new part of the point cloud. So we'll go to our table of contents. We can actually turn off the aligned point cloud. We're going to turn off our map as well. We'll look at a tinned version of this. So we can see it's a much smoother representation of the terrain. We have gotten rid of a lot of those additional triangles because of how noisy it was in this particular area. If we do go from one to the other, you can see just how different these two data sets look like, and we'll cut a profile across it as well so you can see the value, of what it was able to do. Again, here is a profile of this area. So as I zoom in, you can see the profile trend line that it cuts across. If I were to look at this area, the align, you can see just how different the two look like. Obviously, they're sitting within each other like they need to, but the noise from the L1 is causing you much less accurate representation of the terrain itself. And we can actually compare and actually view. Let's view these points a little bit bigger, so you can see them better. In this particular area, we're looking at roughly 2 centimeters of noise, 3 centimeters of noise, 2 to 3 centimeters of noise, something in that ballpark. Whereas we traditionally were before we ran any smoothing, looking at nearly 10, 12 centimeters of noise. So we reduced the noise from 10 to 12 centimeters down to 2 to 3 centimeters by running the smoothing tool. Lastly, what I always like to show is one tool that we talked about in the presentation, but is the Image Explorer tool. So the Image Explorer tool essentially is going to allow for you to click on the point cloud itself and open up all the images that were taken in that particular area. So I have the Image Explorer tool open. If I click on this corner of the building, it's going to pull up all particular images in that area of the building. Same thing goes if I click on the railroad down here. It's going to pull up all those pictures. So you can imagine if you're flying a lot of different areas out there, this is actually going to give you so many different ways you can analyze the data. If you want to look at some stockpiles over here, it's going to pull up all those images that you need for this. So it's a great tool. It's invaluable in my opinion, especially if you're trying to do some classification, you don't know what you're looking at. Open up the Image Explorer tool and it'll give you an idea of what that is you're trying to classify, or if you need to get rid of it or whatnot. So the Image Explorer tool is one of my favorites, and I think is really going to allow for you to build the data set that you are looking to build. Well, thanks everybody. That's kind of the last feature I wanted to show you on how we can enhance the data from the DJI L1, from the updating the LAS to assigning a point source ID, doing some strip align and assessing the data if actually needed to do a strip align tool, smoothing out the data to decrease the noise, and one of my favorite tools, the Image Explorer tool, which we just finished up with. I appreciate it. If you have any questions, please do not hesitate to reach out to me. My email is matt@lp360.com. I look forward to working with y'all and hearing how I can earn your business. Thanks so much.
Thanks, Matt. That concludes our webinar for today. Thank you to all our presenters for their valuable insights. We hope we've educated you on the many benefits of using the DJI L1 in conjunction with the LP360 drone. If you have any questions or would like more information on anything you've heard about today, please contact us at sales@geoqaustralia.com. Thank you.